Today we focus on BPMN, a notation used to model business processes. The BPMN notation is widely used to document processes and is similar to UML activity diagrams, event-driven process chains, YAWL models, and many other notations. These all have in common that there can be AND, XOR, and OR splits and joins. Given their widespread use, we often need to map discovered process models to notation similar to BPMN. This explains the focus of this lecture. In the last lecture, we looked at different process modeling notations and the impact that they have on the discovery process. So for example, we discussed the notion of representational bias as something being very important for process discovery. There are many different notations that one can use. So battery nets, transition systems, etc. Today we will focus on BPMN, not so much as a representational bias, but more as a notation that people in practice often use to visualize process models. So business process model and notation, as is the official term, is also known as the business process modeling notation. In this lecture, we will simply refer to it as the BPMN notation. BPMN emerged in 2004, and it is at this point in time an OMG standard. And here you can see some references if you would like to see some more information. It is highly relevant because it is supported by many vendors and used by many people in industry. That's why we often want to convert our results to this notation. On the other hand, there is nothing new. It is very similar to UML activity diagrams and event-driven process chains, as we will see later in this lecture. Typically, only a small subset is being considered, and we will do the same here. So what are the notational elements of a BPMN diagram? We have tasks or activities, we have splits and joins, we have AND splits, XOR splits, AND joins, and XOR joins, just like we have seen before. There are also other constructs, such as the OR split and the OR join, and we will look at these constructs in more detail. A BPMN diagram starts with a start event, it ends with an end event, and there can be other types of events, for example, events triggered by a clock or events triggered by a message. There are also more advanced constructs like the deferred choice. So here you see a pattern where after X there is a choice between Y and Z, and there is a race between a clock and a message. If the message is received before a particular point in time, we do Z, otherwise we will do Y. So let us take a look at an example. So here you see a BPMN model with the corresponding notational elements. So first of all, we have the start and the end event. Very clear in this diagram. Then we have the XOR splits. We also have XOR joins, in this case 3 of them. We have an AND split and an AND join, as are indicated here. And this is how we can model this particular process. We have seen this example model before, but it's important to realize that just like battery nets, BPMN models have also a token-based semantics. So we can replay this process model for a particular scenario. So we first execute activity A, then we do the AND split, we go to the XOR split, and after that we do D, then we do C. We first have an OR join, then we have an AND join, we synchronize the two signals, and we can do E. After doing E, we decide that we have to go through another loop. So we execute activity F, bring the model back to a state before the activity is in the middle. We do a B, we do a D, we do an E again, and now we choose the path H leading to the final state. So this is one run of the model, and of course this model allows for infinitely many behaviors. Now we take this model and we have changed the AND split, XOR split, XOR join, and join groups of gateways by a so-called OR split and OR join gateway, indicated in yellow here. So still the original behavior is possible, but we can, of the three activities in the middle, we can take any subset of them. So we can execute all three of them, we can execute two of these three activities, or just one of them. So most difficult is the notion of an OR join. When can we move on from an OR join? The informal semantics is that you wait until all the work has been done. In other words, there is no need for any further synchronizations. So to make this more clear, it helps to look at concrete examples, even though they are a bit abstract. So here we have a process model where we first do an A, then we start three parallel paths, one involving B, one involving C, the other one involving a choice between D and E. Then we do an OR join, and finally we do an F. So you should now be able to understand what the traces are that are allowed by this model. So please think about how many traces are possible in this BPMN diagram. The answer is 12. There are 12 possible traces. First of all, we have to take a choice between D or E, and then we execute the three activities that can be done in any order. So we have 3 times 2 times 1 multiplied by 2, the choice between D and E. So in total, there are 12 possible traces, and here you can see them. So the OR join has a semantics where we wait until everything has finished what should happen before. But it is unknown what the exact number of synchronizations is. Here the synchronization is always 3 out of 4, but that does not need to be the case. Let's take a look at another model, and now I ask you the question of soundness. We have defined soundness very precisely for workflow nets, but of course you can also define them for other notations like the BPMN notation that have a well-defined start and end. Is this model sound? The answer is no. There are many potential deadlocks. Here you see the deadlock where after doing A, there is an OR split. So we can do B and C and D, but we can also just do B or just do B and D as is indicated here. So if we choose to do B and D, but not C, in that case, we cannot synchronize 3 flows. Whereas the gateway before F requires that on all 4 of the incoming signals, there will be a token. So this is, this construct does not make a lot of sense here, because typically you would like to combine an AND split with an AND join, or an OR split with an OR join. And here that is not the case. So there are many deadlocks here. We can take a look at this BPMN model, which has a more complicated combination of gateways. Is this model sound or not? The answer is no. If you look at all the behavior of this model, there are several potential deadlocks. If you look carefully at the diagram, you will see that C and E should happen together, or D and F should happen together. If that is not the case, then you will run into a deadlock trying to synchronize flows which cannot be synchronized. So this is one possible deadlock where you do a C and F, and then you cannot synchronize. Or you do D and E, and then you also run into a deadlock. There are also behaviors that are possible. So here you can see some traces that indeed lead from beginning to end. For example, we can do first A followed by C, and then at the bottom we need to do B followed by E. Then we can synchronize both flows and do G at the end. So there are also several good traces, but this model also has deadlocks. As I said at the beginning, the BPMN notation is very comparable to UML activity diagrams or to more classical notations like the so-called event-driven process chains, simply referred to as EPCs. What you see here in this diagram is an EPC which has exactly the same behavior as the BPMN model that we showed at the beginning. So what are the notational elements of an EPC diagram? We have functions that corresponds to activities in the BPMN diagram or activities in the way that we have spoken about before. You have connectors, they correspond to gateways in the BPMN notation. And again, we have XOR, AND, and OR, also the inclusive OR, to model the same types of behavior as what we have seen in the BPMN notation. The OR join deserves some special attention. And to illustrate this a bit, that this is a difficult concept and that you should be very careful about it, I'm going to show you a paradox. What you see here is that there is one EPC diagram having two OR joins. And remember that the understanding of an OR join is that everything that has been done before has been done. In other words, no tokens may arrive. So if you look at this initial situation, where there are two tokens in front of these two OR joins, the question is, can additional tokens arrive through these two other inputs that these two OR joins have? Well, suppose that you say that is not the case. Then one OR join should block, and because of symmetry, the other should also block. So both should block. But if they both block, that means that you will never receive a second signal, so the OR join should not have waited. So you create a contradiction. If you block, you should not have blocked. So okay, so blocking is not an option. So now we can say, okay, if one is not blocked, then by symmetry, the other one should also not be blocked. So they both can go. But if they both go, then there will be signals on the OR joins on the other inputs. So this is again a wrong choice because we should have waited because there was still a token arriving. So due to symmetry, you can clearly see that there is a paradox in which all the choices are wrong. So this is illustrated that you should be very careful when interpreting these OR joins. And it also shows the complexity of some of these process modeling notations like the BPMN notation. What I stressed already before is visualization of the discovered models is different from the representational bias. So often we convert to a BPMN model to make a model that people would like to see, and it is unrelated to the representations that are used internally by the process discovery techniques. There are a few miners that work directly on BPMN models. Most of the miners will discover Petri nets, causal nets, process trees, heuristic nets, and all kinds of other notations that are suitable for process discovery, and only towards the end they are converted to BPMN. Sometimes the conversion is a bit lossy, that you generalize the model a bit or make it a bit more specific. Here you see a screenshot of the inductive miner that provides a visualizer that shows the process tree as a BPMN model so that people can more easily understand what it represents. This concludes this lecture. I hope that you now understand more of the BPMN notation that was already introduced in chapter 2 of the book. Thank you for watching and hope to see you soon.